Welcome to new section 7.1, integration by parts. And this is the first video in this series of integration by parts. Now for integration by parts, the first thing is, when are we going to use integration by part? We are going to use it if we have a product between two different type of functions. So just let me write down here is a product of two, let's say, almost basic different type of functions. I think it's safe to say that. Now, what are the type of functions? And what I'm talking about is, you remember we have the family of logarithmic function, something like len x, log 2x, maybe len 3x, and so on. This is the logarithmic family. We have the family of the inverse function, sine inverse of x, arc cosine of x, which is cosine inverse, and other inverse functions. We have the power functions, which is x squared, x cubed, square root of x minus half, x minus 5, etc. Even x squared plus 2x plus 1, anything polynomial power is in this category. We have the exponential functions, which is ex, 3x, 2x, 2 minus x, and so on. And finally, we have the trigonometric function, which is sine x, cosine x, secant x, and so on. Okay, so we have those mainly the most 5 familiar functions. And if I have a product between two functions from this category, for example, I have a product from len and polynomial, something like, for example, let me just write an examples here, something like x power 3 len x dx. This is polynomial and this is logarithmic. So here we have to use integration by parts. Or for example, I have integral of x sine inverse of x, and so on. Those are all common for integration by parts. And for integration by parts, what we will do, one of these function I will call it u. So one of them I will call it u, the other part I will call it dv. So part is u, this is why we call it integration by part, the other part is dv. And the formula for that is the following. Let me just erase this to have a space here. And the formula is this one. Let me do it in red. As I said, one of them we will choose to be u, and the other part will be dv. And the formula is uv minus integral v du. That is the formula that we are going to use, and this is the integration by parts. Now, the question is, how do I find which function I should choose as u? We will use this hierarchy. If the first function you see is logarithmic, that is your choice for u. Now, if you don't see logarithmic, now the first function you see is inverse, that is your u. If you don't see inverse, then you go for the power or the polynomial, and that will be your choice of u. And then the exponential, and finally is the trigonometric. And that would be my choice of u. And always your choice of u should be consistent with the rule that your u should be something that is easy to differentiate, something you can differentiate it, and the answer is simple. And the dv, something that is easy to integrate. Why is this? You will see it in the next video when we start solving examples. Okay, welcome back to section 7.1, integration by parts. If you can notice in this question, we have to evaluate the integral of x times cosine 5x dx. If you remember from last time, we said if we have two different functions of different type, this is just a polynomial function or a power function, and this one is a trigonometric function, the best way to solve such a question is we use the integration by parts. And in order to use integration by parts, we need to identify one function as u and the other function as dv. So we have to choose u and we have to choose dv. Now, what is the best strategy that will work 90% in choosing u is using this keyword here, which is LIPET, and this is the way we choose the u. So if we see first a logarithmic function, that will be our first choice to be u. If we see inverse function first, that is the candidate for u. If we see a power function, x squared, x cubed, x minus 5, x power half, this will be my first choice to be u. And then if I see an exponential function first, that will be my u, and last choice for a u is the trigonometric function. So if we look here, this function is power function, x to the power of 1, and this one is a trigonometric function. So according to this rule, which will work 90% of the time, x should be my u, and everything else will be my dv. That's how we use the integration by part. We take it part by part. So let me go here and we do that choice. So now, as I said, my u will be just x, and my dv will be everything else. Now this is u, so everything, including the dx, will be my u. So this is cosine 5x dx. The next step is we need to find two pieces of information. We need to find du, which means the derivative of this function, and we need to find only v, and v is the integration of this function. So what we will do here is, here we will take derivative, and on this side here we will take, or we will do integration. So two things we need to do, derivative and integration. Let's do it together. Derivative of x is just 1, and then don't forget you write dx. Now integral of cosine, this is just a sine. We keep 5x, and because of this 5, we need to divide by 1 over 5. So that's what we will do next, 1 over 5. Now my setup is ready to do the integration by parts. So if you remember the rule of integration by part, I will write it in red just in case if you forget it. Integral of u dv is equal uv minus integral of v du. And that is the integration by parts. And that's all what we need to do. So if we go back to our question, it's just a matter of writing x cosine 5x dx. Now remember, this is my u and this is my dv. Now, how we do it? The formula says uv, so you take u and you multiply it by v. It's kind of a cross. Okay? And then you do v times du, so it's kind of a cross this way and then going the other way. So if we do u is x, v is 1 over 5 sine 5x minus integral of v, which is 1 over 5 sine 5x times du, which is just 1 times dx, and usually we just write it as dx. That's how we start doing the integration by part. Now, there is another integration we need to evaluate to end up this question. So the other one is this one here. This would be 1 over 5 x sine 5x minus, if we take 1 over 5 outside, we just need to do the integral of sine 5x dx. And the final answer will be 5x minus 1 over 5. Now we need to do this integration. You do this integration here. What is the integral of sine? It is minus cosine 5x. And because of the 5, I need to divide by 1 over 5. So it would be minus 1 over 5 cosine 5 plus the constant of integration. And that's what we should get. If we simplify, the final answer would be 1 over 5 x sine 5x minus, and there is a minus, so it will be a plus, 1 over 25, because 5 with 5 is 25, cosine 5x plus a constant c. And that is my answer for this question. This is the final answer. So please, if you have any question, let me know in the comments. Going very fast about it, you have u dv integration by part. This is the formula that we will use. Now, how we define u? Using the limit rule. And because we have two functions, one of them is polynomial or power function, the other one is trigonometric, we have to choose u to be the x. And dv to be everything else, which is this side. And then from u we get du by differentiation, and from dv to v by integration. And then we use the rule uv minus v du. Let me go now and solve another question. Question number 2. And in that question, which is number 2, let me do something with the inverse. So question 2. Evaluate, let's say cosine inverse x dx. Now, why do we need to use integration by parts? We have to see two functions, but here we see only cosine inverse. So what do you think is the function that we don't see here? If you guess it correctly, that function should be 1 or x to the power of 0. So again, we have to go back to the limits to choose the u. Now we have two functions. One of them is the power function, x to the power of something, which is p. The other function is trigonometric, so this is now p. And the other function is the inverse. Now, who has the priority to be u? Is the power or the I? We go through this word and we will find that the I comes first. So what we will do is I will choose my u to be cosine inverse of x. And my dv will be everything else. Now, if you choose cosine inverse to be u, everything else means just dx here. Or you can say it is 1 dx, but it doesn't matter. Now we need to find du and we need to find v. And just a quick reminder, here we need to do differentiation, so derivative. And here we need to do integration. Just a quick reminder of what we need to do. Now, if you try to find the derivative of cosine inverse, you have to go back to calculus 1. And the answer would be -1 over square root of 1 minus x squared. And the integral of dx is just x. We have those two pieces of information. We need to put them together. So the integral of cosine inverse of x dx, according to the integration by part, it is u times v, which is this times this, minus this times this. So it will be minus integral of v du. uv is easy. It is x with the inverse function minus integral. V is just x, and du is this one. Sorry, I forget to write dx here. So it would be negative over 1 minus x squared dx. The final step is, just let me write it down. First of all, you have a negative and a negative. So if you combine them, you'll just get a plus. And then you have x over square root 1 minus x squared dx. Now, in order to find this integral, we will use whatever we have learned in section 5.5, which is the usual substitution. Why the usual substitution? Because here we have an inner function, which the derivative of this is almost here. So that's how we will do it. I can do it in a separate piece of paper here. Let me do it here just for practicing. And then we can copy and write the final answer up here. So just let me use a different color. I will do it here as short as I can, and I copy the final answer. Now, let's use the substitution method. So my t will be 1 minus x squared. That means dt is negative 2x dx. So how much dx? Dx is just 1 over negative 2x dt. Now, if you want to find the integral of x 1 minus x squared dx, we do the substitution. This would be just square root of t, because this is just t. The x in the top will stay x in the top. Now, how much dx? Dx is this one. So we write it down here, and it will be 1 over negative 2x dt. A little bit of cancellation could happen here. This cancelled with this. The minus 2 can go outside. So the answer will be negative 1 over 2 integral of 1 over square root of t dt, which is the same as 1 over 2 integral of t to the negative half dt. And if you do negative half, you have to add 1. If you add 1 to negative half, it will be half, and then you multiply by that number, and the final answer will be just negative t to the power of half. If you go back to x, this is just negative square root of 1 minus x squared. This is a quick recall of what we do in section 5.5. We take my t, the inner function, to be everything inside the square root, and then we find dt by finding derivative, which is this one, and then we find dx alone, which is this, and we substitute it here. We get this as answer. So the final answer up here, I'm sure it will be just this one, x cosine inverse x minus square root 1 minus x squared plus c. Please try to solve this question by yourself at home, and let me know in the comments if you get the same answer as I get it here. Thank you.